This video is a continuation of the previous example where we were testing the claim that the mean cotinine levels for non-smokers exposed to tobacco smoke is higher than that of those non-exposed. But this time we're going to construct a confidence interval to test that claim instead of doing a hypothesis test. So before we actually construct the confidence interval, I want to talk real quickly about the alternative hypothesis and the null hypothesis. So let me just write the null and alternative hypothesis down again from the previous video. We said that mu1 is equal to mu2 is the null hypothesis, where mu1 represents the cotinine levels for the group exposed to tobacco. And then we said that mu sub 2 is the mean cotinine level for those not exposed. Okay, so we assume that they are the same. We assume that the cotinine levels are the same. And the claim that we're going to test is the claim that it's actually not equal to each other. It's not the same. We think that the cotinine level for that first group is actually higher, so greater than the cotinine level for the second group. So let's take a look at the null hypothesis real quickly. If mu1 is in fact equal to mu2, so if this is true, then when we look at the difference, mu1 minus mu2, that difference would equal 0. So if the difference between the two cotinine levels is 0, then that means that the cotinine levels for the two groups are actually the same. But in the alternative hypothesis here, if mu1 is in fact greater than mu2, then when I subtract mu2 from both sides of that inequality, the difference, so mu1 minus mu2, we can see here that that difference is greater than 0. So if you get a difference or a value, right, that's greater than 0, a difference greater than 0 means that that difference is going to be a positive number, okay? And this is really important when we start looking at the confidence interval and how to interpret and read the results. So here, how do we know what would be an appropriate confidence interval? So what is appropriate depends on if you have a one-tail test or a two-tail test, and it also depends on the significance level. So from part A, we test the claim by using a significance level of 0.10. And then when we look at the alternative hypothesis, we see here that we have a one-tail, more specifically, right tail test. So because this is a one-tail test, the entire right tail of the bell-shaped curve here contains that significance level. So back in part A, when you did the hypothesis test and we did a right tail test, we shaded the critical region in the right tail. But when you build a confidence interval, the confidence interval, we look at the left tail and the right tail, but we got to make sure that our critical region in the confidence interval matches up with the critical region in the hypothesis test, because that's the only way that we'll actually come to the same conclusion as well. So in the hypothesis test, the right tail had an area of 0.10, and so the left tail also has an area of 0.10. So this means that whenever you have a one-tail test, you have to double your significance level before you can calculate your confidence level. So here, the confidence level, I'll shade it in blue, right, is the region in the center, right, between the two tail regions. So this is where we're going to find our confidence level. So our confidence level here is going to be, so I'll write it, confidence level, 1 minus 2 times alpha. Okay, so again, you always double your alpha anytime you have that one-tail test. So our confidence level that would be appropriate for this test would be 1 minus 2 times 0.10, or 1 minus 0.20, or 0.80. So this tells us that our confidence level is going to be a 0.80. So we're going to build an 80% confidence interval. And I'm going to go straight to the calculator and use the calculator function to get that interval. So on the calculator, you're going to choose the option 2 sample t interval. So 2 sample because we have 2 independent samples, and t, we're choosing t because sigma is unknown. So we're always using that t-test, and then interval because we're building a confidence interval. When you put in all the relevant information, the calculator is also going to ask you if you want to pool your data. Just choose the option no, and then it's going to give you the following confidence interval. So you'll get 13.423 up to 75.037. So now let's interpret this result, right? How does this help us make a decision about the null hypothesis and the alternative hypothesis? So if you take a look at this confidence interval says this. It says we are 80% confident that the difference between mu1 and mu2, right, is a value that is between 13.423 and 75.03. So notice that that difference does not contain 0. So the fact that the difference from our 80% confidence interval does not contain 0, it means that mu1 minus mu2 is not equal to 0, which then implies that mu1 cannot be equal to mu2. In fact, the fact that the confidence interval contains only positive values, so notice 13.423 to 75.037 are all positive values. This then implies that the difference is greater than 0, therefore mu1 must be greater than mu2. So here you would say that we are 80% confident that the difference between the cotinine levels of the two groups, right, is a positive value, which implies that the cotinine level for the group exposed to tobacco is in fact greater than the cotinine level for those not exposed. And notice that that conclusion matches up with the conclusion from the hypothesis test. All right, so I'll write this down for those of you who wanted the notes in detail. So you'll say, since the confidence interval does not contain 0, okay, this suggests or implies that exposure to second-hand smoke appears to have the effect of being associated with greater or higher, whichever word you want to choose there, amounts of cotinine. Let me spell cotinine correctly. Amount of cotinine than those not exposed to secondhand smoke. Okay. All right, I'll show you real quickly how to do this on your calculator. So the calculator function that you would use is you would press second, tab over to test, choose option 0, which is the one after 9 to sample t interval. It's going to ask you to put in all the sample data information, and then notice you got to choose the correct confidence level. And then for being pooled, just say no. And then here is your confidence interval. And then again, I tell students always check down here to make sure that you typed in all your sample data correctly, because if you don't, it could lead you to a different confidence interval.